Hello, welcome to Astronomy Live. Tonight, webcasting the close approach of asteroid 2014 JO25, which is the streak you see here on the left side of this image. So, I've had to go to sort of a plan B situation here. And that's simply because of the weather. So, I got up and got ready to start taking images of this asteroid, but ran into a problem. And initially it looked clear at my location here in Florida. And then when I went to go set up the telescope, I look up and lo and behold, it is completely cloudy. Not a single star visible in the sky. So to be able to provide live images of this asteroid, I'm going to be using itelescope.net to remotely take images using a telescope in New Mexico, where the weather is much more favorable. Okay, so let's see here. All right. Trying to get everything arranged here. Let's see, if I refresh the latest image, it should update it. There we go. So I have to occasionally bump the telescope to get it to continue tracking the asteroid. Unfortunately here, because I'm using itelescope.net, I can't use my custom tracking software, and itelescope.net does support minor planet tracking, so that the telescope tracks along with the asteroid or comet, but I can't seem to get that to work correctly at the moment. If I try to plug in the orbital elements of the asteroid, it seems to want to send the telescope to the wrong location. And I think it's a formatting issue with the orbital elements that I'm feeding it from FindOrb. So I'm not going to try to troubleshoot that right now. It's much easier to simply specify the exact coordinates that I want and get it to display those coordinates. So here's the image. This is being taken with an ST4000 XCM camera, which is sort of the big brother of my camera on a Takahashi refractor. And you can see the asteroid is clearly moving very quickly. This image is just 60 seconds long, and it's already traveled that distance across the image. So you can see why I have to be quick on my feet here about updating the coordinates, because it doesn't take very many images before it crosses the field of view completely. So on a separate window, I've got the telescope's current status updating for me, and when a new image comes in, then I can refresh it and keep showing you live images of this asteroid. So the asteroid is actually longer than originally thought, although in terms of diameter, I don't think it's much different than the NOAA's mission suggested. But the thing is, it's about 1.3 kilometers long, and it's extremely elongated. It's sort of peanut-shaped. It's actually appears to be what they call a contact binary, where it's got two lobes from what were probably originally two rocks that have come into contact with each other and formed a single object in sort of a low-speed collision situation. And it looks very similar to Comet 67P in terms of the overall morphology of this thing. It's that's another example of a contact binary where you have two lobes and a neck region. And that's what this asteroid actually looks like. But it's currently approaching Earth, and at its closest, it'll be a little over 4 times the distance to the moon, which is quite close for an asteroid this size. You know, a 1.3 kilometer asteroid, even if that's an elongated asteroid, that's still a big potential impactor. And if it were to hit, it would devastate a large region on Earth. And so, you know, as astronomers and just as people, we need to be concerned about these kinds of objects because they can sneak up on us. This object was approaching from about the direction of the sun, and it was only discovered in 2014. So we couldn't see it until now, until the day of close approach, because of the angle it came from. And fortunately, we had seen it on a previous orbit, so we knew about it uh, before this orbit, before it made this particular close approach. But still, 2014, that's only 3 years ago. And that's not much warning, especially for an object this size. If it had actually been on an impact trajectory, it's doubtful that 3 years would have been enough to do anything about it. So that's the concerning thing. Um, Obviously, we need more eyes on the sky. We need more monitoring of near-Earth asteroids so that we can have enough warning about these kinds of objects, so that something could be done if one were found on an impact trajectory. Now, this is the closest approach of an asteroid this size in a few years. Let's see, when was the last time we had something this large, this close? It's been a number of years, and it's going to be, I think, about another decade or so, at least until the 2020s, that we have another asteroid roughly this size approaching this close to Earth. So, these things don't come. Uh, these things don't come this close at this size very often. Now, smaller size asteroids come closer all the time. Asteroids under a kilometer in size are crossing much closer to the Earth-Moon system on a regular basis because there's more of them. And, once you get under 500 meters, it's not uncommon to see those passing between the Earth and Moon on a very regular basis. And obviously, the smaller the size, the less damage it can cause. But still, you could have a situation where you have an impactor large enough to take out a city, and there's even less warning, where you don't even get 3 years of warning. You maybe get 24 hours, 72 hours, depending on uh, when you found it. And even asteroids this size, one over a kilometer at its longest, they have to be pretty close to Earth for us to be able to detect them. So here we go. Here's a new image. You can see it crossing between a couple stars here, and moving along quite quickly. So let me see here. I'm going to need to move the telescope to a new set of coordinates after this next image, I think. And I had been trying to get set up for a second telescope to start taking images, but I don't think I'm going to be able to make that happen. Looks like that's... Oh, is it no longer in use? It looks like it's no longer in use. It did come available. I don't know, though. Yeah, the second telescope I was thinking about getting online, it's got a slightly wider field of view, but not enough to really make a huge difference. I'm not going to try switch telescopes midstream here, but I am going to have to update the coordinates on this thing. So, okay, starting image download right now on the last image. And then I'm going to give it some updated coordinates. So it looks like I can keep it in there for only about 10 minutes or less before I have to update the coordinates on it. I mean, it's moving along at a pretty good rate here. And this telescope, the field of view is about 1.5 degrees in along each side. Okay, stop the current run and update the pointing position. So here comes the last. Let me update the image here. Yep. So you can see it there. And now I'm going to give it a new set of coordinates. So itelescope.net is very easy to use. If you know what you're doing. Well, actually, there's options for all skill levels, beginners through advanced users. But in my case, it's very easy to use because all you have to do is plug in the coordinates you want and tell it how many images you want, what the exposure duration should be. You can even specify binning of the images, what color filters, if any. In this case, there are no color filters because it's a one-shot color camera, which is easy for beginners to use. It's Telescope 3 on iTelescope Network. And I've started the new imaging run, so it's going to slew the telescope to catch up to the asteroid and start imaging it again. And in the meantime, I am going to see. Okay, so it's updating the pointing right now. I'm going to see if I can. I'm going to try to create a custom plan. So when you set up an observing plan, which is any time you want to take an image or multiple images, it creates a text file that basically programs the telescope and tells it what to do. And it's human readable, and so I can basically take the observing plan that I just gave it and try to see if I can basically get a running set of images. So that instead of having to manually update it, it will automatically track to the next set of coordinates at the appropriate time. This is more of an advanced feature in the sense that you have to do a little bit of text file editing here. It's not too difficult, but you do have to know what you're doing. So let's see here. 30. Okay, it's taking, or it's downloading the first image of the new run. And I apologize if you guys are frantically asking questions in chat. I haven't even had a chance yet to try to open that up and see what's going on. Kind of got my hands full. It's actually a lot more hands-on to be able to do it this way than to be able to do it with, say, the teletrack software I wanted to use today, which would be completely automated. Okay, should have the new image available. So let me refresh the page. There we go. So you can see the asteroid streaking through there again. Oops, did not mean to do that. Sorry about that. Okay. I'll come back in here. Oh man, this thing's in decimal. The format the text file uses isn't the most convenient for me at the moment. It gives it to me in decimal degrees when what I really want is it's actually decimal hours in the case of right ascension, which is not the most helpful thing. But if you simply divide by 15 from decimal degrees, you get decimal hours. And I know I'm probably talking gibberish to most people, but it's just a matter of coordinate format conversion to make it compatible with iTelescope. So I should have a new image available, I think. Refresh the page here. There we go. And now I can come back in here. And then okay. See if we have an image available here. And we do. Gonna have to bump the telescope again here shortly, but hopefully I can get this plan working. I'll try this. This might fail miserably, but created a custom plan here. Okay, let's see. I got one more image. It's probably getting ready. Yeah, it's getting ready to leave the field of view there. I'm gonna abort that script. My observing plans. So now I just have to upload the custom plan I just made. Okay, and I'm going to start a new imaging run with that plan. And we'll see how this goes. Unfortunately, it's not really designed to do exactly what I'm doing. Like I said, there is a way to get it to track minor planets directly, but I can't seem to get it to do right. I can't seem to get it to read the orbital elements correctly at the moment. So instead, I've manually specified the coordinates I want it to go to. But the thing is, I can't tell it at this moment, at this minute and second, I want you to be at these coordinates. Instead, it just follows the plan. It says, okay, I'm going to take X number of pictures at X exposure, and then I'm going to move on to the next step. So I'm estimating how long that's actually going to take, because although you might say, well, 10 images at 60 seconds should be 10 minutes, it's not exactly 10 minutes, because there's downtime in between each exposure where it's downloading the photo, creating the preview image of the photo, and getting ready to take the next photo. And so you end up actually over 10 minutes. And so I've estimated there's maybe 1 to 2 minutes of downtime in a 10-minute series. That might be too much. That might be generous. But basically, I've got a series of 8 images at each set of coordinates, and I might actually be starting this plan a little too early, because the first position is where the asteroid's actually going to be at 30 minutes past the hour, and we're about 7 minutes out from that. So we'll see how it goes here. The asteroid may or may not be in the field of view of this first image it's about to take. So we'll see how it goes. It's starting that first picture right now. And then it's going to take 8 pictures. Oh, it's actually updating the pointing right now to make sure it's pointing at the right position. So we might be okay, because you also have to give it a lot of lag time going into the plan, because it takes it a minute or 2 or even 3 to get everything running, where it slews to the target. It takes a quick test image to verify that it's pointing in the right location in the sky. Then it starts the autoguider running if you've selected that option. Then it waits for the autoguider to settle down, making corrections, and then it starts the actual imaging run. So that whole process takes a few minutes, and that's what it's doing right now. But we should be good to go. If it all works out well as I plan, then it shouldn't require me to manually update it every few minutes now. It should just run from coordinate to coordinate. So we'll see how it does. Oh dear. Okay, I've selected the wrong thing. Okay, stop abort script. Somehow it's only taking images that are a few seconds long. How did I manage to do that? Oh. Oh. Interval 5. Oh, I told it 5 seconds. I meant to say 60. Okay, somehow I messed that up really bad. Okay, that's why it's only taking really, really brief shots here. Try that again. Version 2 of the plan. That's okay. We're probably going to be closer to being where we should be in terms of the timing. Let me upload version 2. I thought it was doing pointing updates because it was only taking a brief few second exposure and then downloading it, but it was actually taking what it thought were the images. Okay. So I'm going to reset that script and get it to actually do things correctly. Unscripted plan. Plan 2. Okay. Started successfully. Let's just see what that did. Because it should have saved an actual image here. It did. It's hard to say which one's the asteroid, though. It's only 5 seconds long, so the asteroid's not going to streak noticeably very much. It could be this guy right here. I don't know. It's hard to say. I'd have to actually check it against the known stars to see what's in the image that doesn't belong, in the sense that it's not in the all-sky background plates. All right. So yeah, the velocity of this asteroid, according to Find Orb, the encounter velocity is about 34 kilometers per second. It's moving very quickly relative to Earth. I think I'm just now checking the chat to see what people are saying. Okay. It's trying to find the guide star. It's having some issues here. Could be. No. The weather in the sky looks okay. Looking at the all sky cam, seeing what the weather looks like in north, and it looks fine. But it's having trouble with the guide star. Well, we could do version 3 of the plan and omit the guide star. I didn't really want to have to do that, but we can do that. We can make that happen. Just save it as version 3, just in case I have to go to that. No, it's actually, the guider's actually running now. Okay, good. It's starting the imaging run. Okay. So we should get 60-second exposure now. Yep, taking 60-second exposure. Excellent. The only thing I'm concerned about now a little bit is the fact that this exposure is going to be right on the money for where the asteroid should be. It should be right in the center of the field of view when this picture was taken. I was hoping to lead the target a bit. So my only concern is the imaging schedule is going to get behind here, where it's going to pass out of the field of view before it catches up, which isn't ideal. We'll see how it goes. But at least we should have an image of the asteroid now, instead of an image of very short exposure of stars and asteroids somewhere. Let's see. It may not have. Oh, not found 4-4. Okay, here we go. That's better. There's our asteroid. So as I said, it's starting off in the center of the view, so it's going to pass out before it reaches the point where it should. Okay, let's... That means I'm going to have to interrupt it and start the next series of exposures early. Oh, no, I didn't mean to do that. Sorry. Okay. And while it's doing that, I'm going to go ahead and upload the next version of the observing plan to basically jump ahead in the schedule to the next series of images so that we catch back up on time. Okay. Okay. Second image should be downloading now. Oh, great. It's doing adaptive focus. Okay, well, I'm going to let it do that for the moment, and then I'm going to interrupt it. Telescope's decided it's time for autofocus, which is like an undesired interruption where it stops what it's doing. It goes and points at a nearby bright star, refocuses the telescope, and then resumes the plan. And it's truly necessary because the temperature of the telescope changes over the course of the night, and that causes the metal tube to expand or contract. And that actually causes the focus to shift. And so if you want to be really accurate, you need to occasionally refocus your telescope. So there's the latest image of 2014 JO25. You can see it there as a streak. Come on, autofocus. Autofocus successful. Okay. So now it's going to slew back to the asteroid, or roughly where the asteroid was. But that really messes up the plan. Hopefully it doesn't do that again. It probably will. Okay. Come on. Trying to get it to reset here. To catch up to the asteroid. Okay. Restarted the plan, rather. Again, I'm a little concerned it's going to be a bit behind now, thanks to that autofocus. I would have been right on the ball had that not happened. I think there's a way I can override that. I forget what the name of the command is. It's something like express mode. Yeah, it's like express or something. But I'm not sure if it actually is express, if that's literally the name of the command. If you get it wrong, it'll throw up a script error and it just won't work. But I'm going to try setting up yet another version of the viewing plan, just in case I need to. So it should be yep. Okay. Yeah, it has moved to the next position as planned, and it is taking images. So we'll see how it goes. So Jay Lee asks, just doing rough math, will it come within 1 million miles of Earth? I believe the distance is about 4.5 times the distance to the moon, so that's about 4.5, and this is very rough. 4.5 times 384,400 kilometers. That is about the distance this thing's going to get in kilometers. That is 1.7298 million kilometers. And in miles, that is yeah, about 1.07 million miles. Okay, we should have the new image up. Refresh the page, and there we go. So it's approaching there, the center of the view, as you can see. Probably going to be a little lagging a little behind on this plan. It initiated a little too late due to that autofocus thing. So I may have to bump it. We'll see how it goes. So we'll wait till it gets closer to the edge of the field of view. And then I'll try to bump it. Hopefully I've remembered that version of command. Let's see. Yeah, okay, so it's hashtag express all capital is the command. Okay. So I'm going to save that. Okay, that's going to be the next version of the plan. Is going to be express mode, which will override the autofocus system. Okay. New image is up. Yeah, look at how fast that thing's moving. Okay. After this image, I'm going to update it to the new version of the observing plan, which will hopefully catch up to the asteroid and at the same time prevent the system from going into an autofocus mode, which would interrupt the plan and delay us further. Okay, it's downloading the latest image. So the camera that's actually taking these images, as I mentioned earlier, this is the big brother to the camera I use on my own telescope, and it's the ST4000 XCM. So mine is the ST2000 XCM. It's essentially the same camera with a larger CCD, a larger square CCD, with 2,000, roughly 2,000 pixels on each side. Whereas mine's 1600 by 1200. So it's about twice the size. But other than that, the electronics on it are pretty much the same. Okay. Resetting the plan. Let's see. There's the last image of that last plan. You can see it's approaching the edge of the field of view there already, which is why I'm now resetting the script to catch up to the latest position of the asteroid. And this time, it should skip all the bells and whistles like autofocus, and I think it'll even skip plate solving to verify that it's pointed in the right location. It'll just assume that it is. So I guess you could call this the open loop guidance mode. And actually, because... yeah, we'll see how it goes. Because this is the express version of the plan, oh, is that right? Starting at 3. Yeah, that is right. Okay, good. Just checking. Okay. Yeah, it looks like it is using express mode properly. It's taking the first image under the new plan. The telescope is also reserved for another user to take over in about 45 minutes. So that's when this webcast will have to end. And actually, it'll probably end a little before then, about 30 minutes. They like to have a little bit of buffer time between the start of, or the end of one session and the start of the next one, to make sure that one user doesn't end up accidentally interfering with the next person's reservation. So you can book these telescopes ahead of time to automatically execute plans for you like this, which is kind of nice. Actually, it's really nice. So on a morning like this, where you have an asteroid that's approaching, you could take images of it and be in bed asleep. Okay, it's downloading the image. So if you're just joining us, obviously not using my own telescope this morning, and that's because of the weather. So we're using itelescope.net instead to take images of the asteroid using a telescope in New Mexico, where the weather is much better for this right now. You can see asteroid 2014 JO25 is the streak here on the right side of the field of view. And this was just a 60-second exposure, and you can see how far it's moved in that period of time. So if you're interested, do check it out. They do have, last I checked, they still had the program where they have a free demo for people who are new to it. If you want to check it out for yourself and try it out, they'll give you a little bit of time on the telescope I'm using right now for free. So I guess they don't, it looks like they don't let you get free time anymore. I guess they got rid of that. Sorry. They used to give you a few minutes for free on this telescope as a demonstration, so you could check it out. They do have a demonstration account, but it will only allow you to view the telescopes that are currently being used, but you can't control them. And I should point out that the preview images that you're seeing right now are not fully processed. They're just that. They're preview images. So they're not as high quality as the full images. In fact, this image has only half the resolution of the raw image, which you do get access to if you have a full account. So I'll have all the raw FITS files from the exposures taken tonight by the telescope, and those are full color images, and I can process them myself for higher quality images, and even put together a time lapse, although that's going to be kind of janky because of all the interruptions I've had to have to bump the telescope to keep up with the asteroid. And you can see how quickly it flies through the field of view. If you strung those images together, it would be a fraction of a second. So, but the nice thing about it is if you end up in a situation like this where you have a time critical event, and even if you have your own telescope, if the weather doesn't cooperate and you still want to see it, you can hop online and control telescopes somewhere else in the world. They have telescopes in Spain, New Mexico, California, and Australia that you can use. And you can keep up with the latest astronomical events that way. And these are very high quality telescopes, very powerful equipment, even more powerful than my telescope, and in some cases, way more powerful. I mean, these are some of the best scopes in the world for amateur astronomy. And in fact, one of them holds multiple world records for most distant object observed by any amateur astronomer. So, pretty powerful stuff. Oh, wow. We have a satellite flying through the field of view here. I don't have, kind of kicking myself right now, I don't have Sky Safari set up to see what the view is from New Mexico right now. I'll see if I can identify. Let me see if I can update my location. Oh, come on. All right, well, never mind that. Let's see. Yeah, okay, there's the latest image. Oh, the asteroid's just about to occlude that star, but unfortunately, it's probably going to between exposures. It would have been nice if we could have got the asteroid to actually cover up that star and blink it out for a frame. Usually it'll just miss, though, by fractions of an arc second. You won't see the star actually dim out, but occasionally you do get asteroid occultations. That does happen. And by measuring occultations across multiple points on Earth, you can actually measure the shape of the asteroid itself. We already know the shape in this case thanks to radar observations, but sometimes that is useful. Okay. Let me see if I can... Oh, can I get Sky Safari to plug in the location here? What I don't know is if Sky Safari even has... Oh, it does. Oh, good. It's got the asteroid in its database. What I don't know is whether... yeah, see, I don't think the orbital elements are really up to date on this. I can update them. But I don't think the epoch of the elements are appropriate. Oh, this one might be, right? It's weird. It's like it's got it in there twice. It might be two different epochs. Okay. Let's see, display. Show me which satellites. I'm curious which satellite that was. See if I can identify it here. Come on. Ah, it's processing the last image. Please wait. Okay. Oh, here we go. Yeah. Looks like that satellite was Iridium 14, launched in 1999. So, an old Iridium satellite passing through Draco. Okay, there we go. All right. Cool. Now, obviously, I need to update the script because it's just going to keep happily taking images there. Okay, so I'm going to have to bump the telescope up one. Yeah, the imaging plan I had was running a little behind where it needed to be. So updating it now. Okay. Image file saved. Okay, cool. Okay. Second image should be completed on this run. Might still be downloading though. Whoa. Okay, that preview image might have goofed up a bit here. Oh, there we go. Okay, we're going to do one more series of images after this, and then I'm going to have to shut down the webcast. Yeah, so it was previously thought to be about 650 meters in size based on observations from NOAA, but that was assuming a roughly spherical object, which is not the case here. It's actually about 1.3 kilometers on its longest axis, and it's a highly elongated object. Okay, for that. And let's refresh this. Boom, there's that image. Very nice. And run scripted plan. Run started. Okay. What time is closest approach? Let's see. Do it in that window. I'll let you guys see that, but I'm gonna search for that over here. So according to NASA JPL, hopefully, oh dear, the site might have already gone down. Yeah, I noticed there was a warning on JPL's site that the website would be down for the next 48 hours or so for unscheduled maintenance. This is JPL's Solar System Dynamics site, which is not coming up right now, and I think that's because they're down for maintenance. Oh my goodness, it must be doomsday. They're going down for maintenance. No, it's expected. Let's see. Let's get Find Orb to tell me. So it's not giving me enough. Okay, well, I can just do it that way. Close approach. Here we go. So according to Find Orb and my own calculations of the orbit of this asteroid, close approach will be at 12:23 Universal Time. Closest approach to the center of the Earth, of course, depending on the observer and where they're located on Earth, that's going to vary a bit due to Earth's rotation, either bringing them closer to or further away from the asteroid. But relative to the center of the Earth, closest approach will be at 12:23 Universal Time, which is 8:23 Eastern Time, at a distance of 0.01175 astronomical units. which is about 1.76 million kilometers, or about 1.09 million miles, according to my calculations. So that's according to my own calculation of the orbit. That's not from NASA JPL. And NASA JPL will apparently be down for the next 48 hours. I noticed that little flag they threw up there yesterday on Solar System Dynamics when I was getting ready for this webcast. It's like, oh dear, they're going down for maintenance at just the most lovely time. Okay, still don't have a new image yet. Or is that the new? No, I guess that is the new image. I don't know. Let's see what's going on here. What's the system status? Oh, it's still downloading the new image. Okay. Okay. You should have the new image now. Yep, so these are the last images I'm going to get of the asteroid this morning. The next scheduled reservation is coming up soon. So I'm going to have to end it here after this image, probably. Oh, okay, after this series of images, I see what's happened here. Notice it seems to be going back the other way. Oh my goodness! The asteroid's going back from whence it came. No, actually, I'm pretty sure what's happened here is a meridian flip. So this telescope's on what they call a German equatorial mount. And basically, when an object crosses the local meridian, which is a line going from due north to due south, it has to flip the right ascension and declination around so that it starts tracking the other direction. It's hard to explain how that works. Let me see if I can find like a GIF animation of what a meridian flip looks like. And basically that means the camera is now flipped upside down from where it had been. And the telescope's now sort of pointing the other way, where it's tracking, as it's coming up from the east, it's sort of, the telescope's coming down and tracking it going up. And then as it starts to cross the meridian and go back down to the west, it has to flip around. The whole telescope flips around and starts tracking down. I'm not doing a very good job explaining this, but trying to find an animation here of what a meridian flip looks like. And basically it's necessary with most German equatorial mounts because otherwise the telescope's going to collide with the mount past a certain point, past the meridian. Okay, that is sort of an example of meridian flip. That's not really what I had in mind. Might be a video or something that's okay. Okay, this video shows a good example. So let me just show you an example of what I'm talking about here. So let me skip here to where it starts the meridian flip. So notice the telescope here is pointed up in this direction, but if it kept tracking, if this axis here, you see this bar here with the counterweights, this whole thing would come down this way to track in right ascension. Eventually, the tube would collide with the mount, so it's got to do a meridian flip. So this video shows what that looks like. So he forces a meridian flip to start. See, now it's coming back the other way, and it's going to flip the whole telescope around to start tracking on the other side of the meridian. One of the things I like about having the fork-mounted LX200 is it doesn't have to do a meridian flip. There's no such thing. It just tracks right across the meridian without interruption. So now you can see the telescope's now pointed basically back up the same way, but now the counterweights are on the other side, the telescope tube's on the other side of the mount, and the meridian flip has completed. And so you've basically turned the whole telescope around, and so your images are going to flip around, but you continue tracking without colliding with the mount. So that's why the meridian flip is necessary. That's what it looks like. And that's why the asteroid appears to be moving the other direction now, because the telescope had to do a meridian flip. So there we go. The asteroid's approaching the field of view, the edge of the field of view. And this will be, I think I'll get one more image out of it, and that'll be it for tonight. Okay, starting download on that last image. Okay, let's see. There we go. There's the asteroid leaving the field of view. All right. I'm going to shut down this telescope script now and log off here. But again, I want to thank everyone for coming out and watching, and thanks for joining me on this close approach of Asteroid 2014 JO25. I'll do something with the raw files later, so tune in maybe later tonight or tomorrow, and I'll post some video. Might just be a simple. Maybe I can do that. Maybe I can do like a large panorama of stitching these images together into one long panorama and pan across it to show you the path that was taken by the asteroid over the course of the webcast tonight. I don't know. I'll figure out something to do with the images, but until then, clear skies, folks. Thanks for watching.